So how do you visualize inertial oscillations in a tank? Well, all you need is a rotation tank filled with tap water. And then you need to initiate some disturbance. Okay, you have to use dye to actually see the disturbance. You put some dye into the water, for example. And then you need to initiate the disturbance. You just put an object into the water, disturb it a little bit, create a little initial flow disturbance horizontally, and then see what happens. Okay, you can use dye, or you can use actually a bullet, an object. And we have a little bullet shooting device that we can use. You shoot a little bullet into the water. So now what's the significant feature here? What's the important first step? You have to make sure that the fluid is under so-called solid body rotation, which means that all particles, the tank and all water parcels, move around at the same rate. Okay, and if you start the tank, this might take a while, because initially only the tank material, the tank itself, is rotating, and then through frictional forces it will take a while until everything is rotating. Okay? And you actually test this. You can test this, okay? Because we have an overhead camera. You place this onto the tank. It rotates. It films the movement, okay, of the rotating tanks. You put in a little dye patch at the surface, and you wait until the dye patch does not move relative to the rotating tank. And you can see that on your live broadcast of the, you can see we have a live monitoring system. This is, for all experiments, is very important that you have that solid body rotation first before you do anything else. Okay. All right, so you use dye, or you use this bullet device, and you film from above. And then whenever you see some circular path, circular swirls or so, that's actually inertial oscillations. Hooray! And that's one thing to do. Okay, second bit is, well, gravitational adjustment, okay, of dense water. So what you can do is you can inject denser water, and you know all about denser water. You know, how do you create denser water? Well, you just produce a saline solution, you just add salt, you let salt dissolve, add some dye into it, and have your tank again under solid body rotation. All right, chuck in some dense fluid and watch how it adjusts. So without rotation, what should do? It should fall onto the floor and just horizontally spread. This is what we call gravitational adjustment. Okay, it's to do with pressure gradient forces and stuff like that. Okay? However, in a rotating environment, this initial horizontal spreading of the dense water will turn into a horizontal eddy near the seafloor, as illustrated here on the left. Wow! And this is called geostrophic adjustment. It actually produces an eddy. There are some frictional effects with the seafloor here, but this is the first most important key feature that you observe is this geostrophic adjustment, something that creates an eddy, okay, near the floor of your tank. That's a second process that you can visualize. But there's more.